Welcome to the Grid Mod Pod, brought to you by AEIC. In this podcast, you'll hear from the utility industry's top operations leaders on how their companies are working to modernize and improve our ever-evolving power grid. Thanks for joining us.
Welcome to the Grid Mod Pod, your trusted source for the insightful discussions on grid modernization and the future of energy management. I'm your host, Dr. Elizabeth Cook, Vice President of Technical Strategy at AEIC, and I'm excited to delve into today's special topic with a special guest. Joining us is Alicia Farag, Co-Founder and President of LocusView, which is a leader in the digital thread solutions for asset traceability. Your expertise really lies in industry-funded R&D projects to develop these best practices to standardize assets and the traceability thereof. And I'll let you kind of take over and really introduce your background and kind of how this all ties into the field of grid modernization. So welcome to the pod.
Thank you. Thank you for having me. So a little bit more about my background. I started my career at GTI, Gas Technology Institute, which is an R&D organization for the natural gas industry, similar to EPRI, but on the natural gas side. So I really have that collaborative R&D background, and that's really what I spend most of my time on these days, is continuing to lead collaborative R&D programs, both on the natural gas and electric side now, and also doing a lot of work to convert that R&D into industry standards. So working with standards organizations like IEEE to take the results of the R&D programs and really get them out into the industry through industry standardization. And my focus area is supply chain and asset traceability.
Which I think is an exciting topic for this podcast because, and I like to always ground our listeners to the tie into the bigger picture. So where we were, where we are, where we're headed, or where we ought to go is really important to kind of keep focused. And so this space here is, as we have evolved and built out the grid, the way to keep information was through pencil and paper, and then ultimately computers, then ultimately printed page, and then ultimately filed in storage cabinets. That really became, and as we all know, binders filled with documentation with non-digitized data, it becomes very hard to really look at holistically and really understand your large system full of assets. So a big part of an electric utility is maintaining and keeping the health of all assets at its really pivotal capabilities. So having a technology that enables this from a paper format to digitize, there is a whole work stream in itself that ties to grid mod. So I just want to throw over an easy one for you to kind of introduce, what we're talking about here is there's a term and it's the SCATE program. So what is the SCATE program?
So SCATE stands for Supply Chain and Asset Traceability for the energy industry. And it is a program through IEEE's Industry Connections platform, also with funding from EPRI. And it's a collaborative program between utilities, manufacturers, and technology providers. And the vision for SCATE is that every piece of electric grid equipment and every critical material will have a smart tag on it that links to that physical asset's digital thread. So digital thread being all of the data that's necessary for asset management throughout the asset's life, primarily information from the manufacturer. So all of the ratings, the mechanical and electrical properties, the serial number, the manufacturer, the production date, all of that information embedded into the smart tag so that anyone along the supply chain at any point in the asset's life can just scan that smart tag and get all of that digital thread data. Now, one of the kind of the backbone of the system is a unique ID. So where the primary deliverable of the SCATE program is going to be a specification that defines the structure and content of the unique ID. So the idea is that Every manufacturer will be able to generate their own unique IDs for all of their products during the manufacturing process based on the specification, incorporate that unique ID into a smart tag, apply it to the product, and then anyone from the distributor through the supply chain warehouse to the construction crews to field crews will be able to scan that smart tag and get all of that data in a standardized format. That's kind of the key there, is that it's consistent across all manufacturers. It's the same data model, the same format, so that the utilities, no matter who their suppliers are, they're able to use a common methodology to scan the smart tag, decode it, and get all of that attribute data.
So there's a lot of richness to what you just said from when we think about the expansive need to communicate effectively to really the industry on the capability of this. And so fundamentally, this is not a barcode, it is much more than that, much greater, and has you really tentacles or the ability to change and revolutionize a lot of decision making. However, to do that, you have to have all parties really at the table and driving this awareness, which is things that we have done in the past. So it's not something that's not unachievable, but you really do have to have those industry groups to really support and drive the awareness of it, the creation thereof it. And it is a partnership of our vendor and the utilities that own the assets engagement, which is another unique human journey, I guess. Because when we think about how the grid came, the utilities themselves were the original designers, creators, and developers of these physical pieces of equipment that they connected, 100 years ago. And it wasn't really until the 60s, 50s, 60s, 70s, where the idea was the utility themselves could really offload that expertise, that capability to the vendor manufacturing organizations to make these devices in masses. And so now we're bringing it all back to the table saying, okay, we need to do this together because of everything that's going on in our industry from a grid modernization perspective. You have your aged infrastructure as well as all of these new technologies. And so I just find that this is like one of those threads that has to keep on moving and has to have the visibility and the voice to not hinder progress based on all the things that can happen when you're bringing a massive amount of people together to make decisions. So it's incredibly exciting in knowing that this is happening. And as we know, barcodes just in themselves of what they are to us, this is a requirement to really do everything in regards to the supply chain, which is another big topic of grid mod, right? So what what are examples of use cases that you are specifically seeing the SCATE system kind of overhaul and take, be the cost benefit analysis or the value of a SCATE system?
So we started the SCATE program a little over a year ago, and that's exactly where we started, was at the use case level, because we wanted the use cases to define the requirements of the data model and the unique ID structure. We did a bunch of surveys, interviews, gathered a bunch of information from the utilities, and we came up with about 12 potential use cases. I'll just talk about the top 3. So the first one is mutual aid. And the idea is that we want a more structured digital way for utilities to make mutual aid requests for equipment and materials, and then for those utilities to be able to respond in a more efficient way. Right now, it's a lot of spreadsheets, emails, phone calls, double checking, going out to the warehouse, looking to see if they have the right materials. But with the unique ID and the way that it's structured, we incorporate a catalog level description of the product within the unique ID to a very specific granular level of detail. So a utility that's making a request during mutual aid can use that unique ID structure to define exactly what they're looking for. And then on the other end, the utility getting that request will be able to know what they have in storage and whether it matches the attributes that are being requested. So it should streamline a lot of the mutual aid information exchange. So that's one. The second use case is related to recalls and systemic performance issues. Recalls don't happen that often. When they do, they can be really problematic. And utilities are not able to know exactly where those recalled assets are, or even if they have them in their system, that can be a real problem. It's not just recalls, it's also systemic performance issues that a utility might uncover on their own. If they start to see failures of the same asset, maybe a certain batch number or a certain type of asset in a certain operating environment, the ability to know where all of the impacted assets are is really important for cost-effective management of these issues. But it's even beyond that, because there's like a safety issue associated with it as well. I mean, there's been recalls of like reclosers and insulators, and they can result in like pole top fires that could become a public safety issue. It could even be a worker safety issue. Recalled splices, where you're asking a worker to go into a confined space to find a potentially recalled splice. I mean, that's not a great situation. So being able to do all that through a query of your GIS is much more cost effective, efficient, and much safer overall. And then the third use case is what we call digital as-builting. And that's the ability, another term. That's the ability to capture information during the construction phase in a digital format using things like smart tags, barcodes, scanning, and GPS, so that you can transfer the information into the system of record. This is actually a really powerful concept if you think about it, because right now they're scribbling down serial numbers, redlining, print drawings, transferring that information back to an office worker who has to interpret, is that a 0? Is that an O? An L? Is that a 1?
Right.
And then they have to manually type that back into the system of record. But with a smart tag, it's literally a 2-second scan. You've got all that attribute information, standardized format, can go directly into GIS or the ERP system. No humans, no interpretation of zeros and O's.
So I think, there's so much there again. And, it's kind of rooting or grounding, for no pun intended, our listeners. I think it's a lot from an external stakeholders or those out looking in. The idea of technology is all around us, and we use it in our daily lives in so many ways. And I think we, as the consumers or the customers, or those that are in charge of the advocacy groups, or those in charge of the policy and the regulatory, somewhat feel as if there's common ground in our industry having access and utilizing technology the way they've seen Silicon Valley deliver the different technologies that we have, such as, Uber, Amazon, etc. Right. And those were specific pain points that truly was not existing, but became in existence, and then really help the technology, the data, the information of all of those systems that were available to be used freely created value for us customers. Whereas the utility space, being in a very regulatory confined situation where the data is sacred, and quite frankly, not a lot of data was actually available when people thought it should have been, or because the technology wasn't unfolded or allowed to really scale through. And there's a lot of, security reasons of that. So what you're saying, right, is like you're able to bring in somewhat of the glue that can bring in the awareness of all of these assets that we are just starting to really have a full understanding of the connectivity of the distribution grid. There was a lot of work that went in to really have the full connectivity in the models for our transmission grid. And that's just from a computational model perspective. But when we think about what it takes to operate a grid, it's the health of the assets that we have been using year over year. And so there's a space where we may have taken for granted that the robust conservative system that we build up will continue to run forever. So like when I think about the software as a system, really as a service, SaaS is like exploding, right? And it's impacting hospitals and construction and factory workers, every really industry. And so pivotal to really all of this is the electric utility industry. And that's what you're speaking about, is like creating something that really can connect our systems because of the paper trail that we still all use. So anyway, I kind
Yeah,
of like,
I mean,
what have you seen
yeah,
like in other industries?
just look around your
Design.
house, right?
Right.
I mean, I just like, this is a $1 baby food package that has a QR code on it that you can scan, and it'll take you to a digital version of all of the ingredients, all of the nutrition content, all of the organic certifications, who certified them, whether it's kosher or not. All this information is available on just your baby food. Another one,
Amazing.
this bottle of mezcal has a QR code on it that when you scan it, it will tell you all the traceability information about the agave, where it was grown, verifying that it was from Oaxaca, Mexico, where it's supposed to be made. So, like, if we can do this on the food side, I'm pretty sure we can do it on the electric grid side.
Yes.
And
Oh,
maybe a more relevant example is what we've done on the natural gas side. Like I said, previously worked at GTI on the natural gas side, and one of the persistent issues that kept coming up, again rare but very problematic, was recalls of plastic pipe. And the utilities were just not able to effectively respond to those recalls. They would have to do these broad leak survey programs and then these random dig ups to see where try and find these recalled assets, because they just didn't have the records for it. So to address that, GTI led a program to create a new standard called ASTM F2897 that creates a unique ID for plastic pipe and fittings. And the manufacturers now apply this to all natural gas pipe and fittings that are delivered in the US. And the utilities are able to scan that barcode and decode it and get all the attribute information, like the diameter, the wall thickness, the material type, the manufacturer, production date, lot code, all of that automatically decoded from the barcode and delivered to their GIS. So now when we have a recall, which we still have, it's within minutes. They're able to know exactly how many of that recalled valve they have and know exactly where they are with the high precision location information.
just this little curious. So, what type of backend systems have to be deployed? Like, will these systems be something that is on-prem or on cloud for the specific utility with those assets? Or is there like thinking about the baby food, right? Like, it's a code that literally takes you into a database that's being monitored and maintained by the baby food company, most likely, and maybe even outsourced. So is that kind of the idea? Like each utility will have their own data cloud, or like it's all interconnected and
So utilities already have their systems of record like GIS, ERP, maybe some compliance management systems. Some companies are doing data lakes now where like all the data goes in there and then gets distributed to the other systems of record. So utilities already have like those core systems of record in place. The new part that needs to be added is like the mobile component. So the people in the warehouse that are going to be receiving these assets, they need some sort of mobile technology to scan the smart tag and then get the information into SAP or Maximo. And then the field crews. So this is one of the more challenging parts of this, is integrating it into the construction workflow so that the field crews that are installing the assets can use a mobile application to scan the smart tag and create a digital as-built and document exactly where those assets were installed. So that's one of the things we're actually working on now, is developing a technology roadmap together with the utilities so that they can have a plan for how they're going to build out the technology systems in order to be able to fully leverage these smart tags. And, you know, to get like the true digital thread vision that I described, that does require full integrations with all your systems of record, and that is a multi-year program. But what we're looking at for early deployments this year is smaller scale, lighter touch, low IT systems that can be deployed to just capture the basic information and then deliver it to the systems of record, or like a data lake. So we see this as like a multi-step process, starting with like simple deployments, light touch, but that still address those primary use cases.
So, the whole concept, let's not boil the ocean, let's bring in manageable parts and kind of take that step and sync together. So, just knowing that, all of the different integrated groups and systems, what do you believe are the real world barriers that, need to be overcome?
So it's not a technology issue anymore. There's QR codes, mobile applications, cloud, like all of that is in place. It's really just about getting the industry together. Like you said, it's really about working together with the utilities and the manufacturers. And these work groups that we have, so through the SCATE program, we've got a bunch of work groups, and everybody says this is obvious. Yes, we should be doing this. Like, there's no question about it. Like, once you see the world for what it could be, which is QR codes on all electric equipment, like, you can't really unsee that. You can't, it's obvious that this is something we need to do. So there's really no resistance to it. It's just a lot of collaboration and agreeing on what this data model needs to be, what the unique ID needs to look like. So it's not a barrier so much. It's just hard work that needs to be done. Getting together all the manufacturers and, working through all these detailed technical questions about, are we going to include impedance in the unique ID or not? And do we include installation thickness? Very detailed questions, but that will really make the system successful.
And I guess, one thing, once upon a time, we had all of these engineers and technicians building generators, and they all ran at different frequencies. And so there came a time where all of this community came together. It was like, we must standardize on how fast we want our system to spin. That's why we have the 60 hertz. And then some countries have 50 hertz. They chose different standardization. So what you're speaking of is just the communities coming together, the different entities, and really just standardizing, and then really helps as an industry to give a roadmap to really obstacles do not block the path. They are the path. So just identifying what those are and then working through them. Like under here.
Yeah.
So, you kind of explained this, but what for you, what makes this the right time for something like this? I heard a year ago. So this is fresh and, let's go.
So the best time to plant a tree is 20 years ago, but the next best time is today. So ideally, we would have had this 20 years ago so that now we could be reaping all the benefits of having smart tags all over all the equipment. But we didn't. And so here we are today. But today's really is a good time because so much money is being poured into rebuilding the system hardening, expansions. So as new work is being done on these capital programs for system enhancements, that's the perfect time to be implementing a system like this. And you're really preparing your utility for the next 30, 50 years by having this information, capturing high quality attribute information that's stored in a standardized format in your system of record. The utilities are going to need all that data, whether it's AI, augmented reality, all these advanced analytics, all this great stuff that's coming, all of it requires data. So capturing it directly from the manufacturers during construction, that is the right time to be doing it.
And I'll just share, on the podcast, we talk a lot about data because it is kind of my jive. From a holistic perspective, we have this large machine. And as I mentioned, the transmission grid still has a large amount of additional data that could be extremely valuable, but we have been able to deploy the sensoring, the measuring equipment to really start to bring in that data. And we're kind of in the midst of that reality here in the distribution grid, but it's a 10, if not 1,000 times more assets on our distribution system that completely operates differently than our transmission grid, as well as our generators. I guess when we talk about data, the end goal is when you're looking at anything, you want to look at what is its durability, what is its capacity, ultimately how long or how much life does it have. All of that information should be really available in Nirvana to then kind of prioritize where you deploy your capital and where you drive your O&M. And really, until we have the sensoring and the measuring to extract the data, and this being one of the sensors, right, to be able to do the analytics that you just spoke of, will not put us, we won't, until we have that, we won't be in this position of power to be this agile, flexible, entity that is required to prepare for the future. So I 100% agree with you. 20 years ago would have been great. However, I don't think the computational powers, the analytics, the chips, the data centers were available to us. So it's really, everything's kind of coming together at once, and we're at a pivotal moment. So it's very exciting. So, I mean, thinking about, what is the status of this particular SCATE program in general?
So we've been at it for about a year. We have an incredible working group with utilities and manufacturers. Some of the utilities that are really thought leaders in this program include Alabama Power, National Grid, AEP, PG&E, Black Hills, Centerpoint. Really, it's an incredible group of people that are really dedicated to making this happen. We also have a lot of great manufacturers, from transformers, cable, splices. It's really a great group of people. So we've been working on this for about a year now. We are getting ready to publish the first version of the specification. We're calling it the SCATE specification. And what that first version will include is the overall framework for creating these unique IDs and smart tags, but it'll have the actual unique ID model for transformers as part of the first version. So we're looking to do some early implementations this year with some early adopter utilities and manufacturers, again, focused on transformers. So that's one path that we're working on this year. Then the second path is that we'll continue with these SCATE work groups for all of the other asset types. We've got active work groups for switchgear, reclosers, poles, streetlights, splices, and underground cable. So we'll continue building out the models for those asset types, and then we want to start the work groups for substation and transmission later this year as well.
Very excited.
And then the third,
that's like all of it. We need it all.
Yeah. And then the third leg of the stool is the standards work. So we're publishing this as a specification that can be implemented as is, but we do want to do the hard and treacherous work of converting it into a formal industry standard. So we're working with IEEE as well as some other standards organizations for other asset types to create work groups to convert the specification into a formal standard that'll have all the governance, associated with a formal SDO. So those are the three main goals for SCATE this year.
If there are any utilities listening that are not the ones that you rattled off, what is the best way that they can get engaged and really embrace this great work that you're doing?
Two things. The first one is just get involved with the SCATE work group. We have monthly meetings where we just get an update and present on the progress that we've made. Then we have asset-specific work groups, so the transformers, reclosers, poles. You can join one of those work groups and contribute to defining the unique ID and the data model, but then also implementation tests. So we've done 2 implementation tests already with Alabama Power and National Grid, and we work together with their manufacturers to really test out the unique ID specification. The manufacturers provided the information. We created the unique ID. The field crew scanned it.
Awesome.
And we just learned so much from those implementation tests. So we're looking to do more of those this year. So interested utilities can just reach out, and we'll get them added to the email distribution list for the program.
Okay, well, this is very exciting. Thank you for sharing this great work. I think it's very paramount for the grid modernization journey. So with that, until next time, I'm Dr. Elizabeth Cook signing off, and thank you, Alicia, for sharing your journey, and I look forward to seeing the products as they unravel, become reality.
Yeah, thank you. Appreciate the time.
That's a wrap for this week's episode of the Grid Mod Pod. Thanks for tuning in. We hope today's conversation got you thinking about new and creative ways to improve our power grid. Be sure to subscribe to our YouTube channel to be the first to hear new episodes. This podcast is brought to you by AEIC, the place where operations leaders come together to share knowledge and provide guidance to the electric utility industry. We'll be back with a new episode soon. Until then, keep powering on.